Hello students, myself Tejaswini, lecturer in ENC, SJ Government Polytechnic, Bangalore. Today is the fourth session of the first unit, Introduction and Architecture of PLC. Now let us have a small recap on the last three previous sessions. Okay. In the first session we have studied the definition of PLCs, why we need PLC, and then what are the leading brands of PLCs, application of PLCs, and then we have studied what are the main components of the PLC. So what is the definition of the PLC? In simple terms, PLC, it is a device which is used to control industrial automation. What are the major components of the PLC? One is CPU, Central Processing Unit, then Power Supply Unit, I/O modules, and then we are having programming device, racks and chassis. These are the main basic components of all PLCs. Okay. And in the second session, we have learned what classification of PLCs. How we are going to classify the PLCs and why we need to classify the PLCs. As I already told you, the applications will be having a very small applications as well as big applications which they'll be using the PLC. For all applications, we cannot have the same PLCs. Okay. So we are having two types of PLC. One is modular PLC and the other one is compact PLC. In the modular PLC, it will permit the extension of the modules. That means you can add the I/O module unit, memory unit, power supply unit extra to this PLC. In the modular PLC, all components are independent to each other. We can add on the modules to the modular PLC. And next one is the compact PLC. In the compact PLC, all the components are in the single case. Okay. Here we cannot add on any devices to this compact PLC. All the units like your input unit, output unit, CPU, power supply, everything will be in the single unit. Here everything is decided by your manufacturer. Okay. That is why it is called compact PLC. It is also known as fixed PLC or integrated PLC. Again we classified the PLCs based on I/O systems and based on application ranges. Based on I/O systems, we classified into digital I/O system and analog I/O system. If we are using your input or output signals or digital, then we can go for digital I/O systems. And if you are using the continuous signals like pressure, temperature, etc., you can go for analog I/O systems. And then again based on application ranges, that is based on I/O devices, how many inputs and outputs we are using for our applications. We are having different types of PLCs. Pico or nano PLCs, micro PLCs, then small PLC, medium PLCs, large PLCs and very large PLCs. Okay. And in the third session, we have studied what are the differences between the relay logic control and PLC logic control. Though those two are doing the same work, that is, those two are performing the logical computations, then why today everybody is preferring the PLC logic control. So what are the advantages and disadvantages? In the relay logic, it is nothing but it will be having so much of wiring. That is the main disadvantage of the relay logic control. But in case of your PLC, there will be less wiring and even the scan time is also very less in case of PLC compared to your relay logic control. Okay. And in today's session, in today's lecture, today we are going to see what are the PLC's advantages and disadvantages of the PLC. Okay. Then after that we will solve some MCQs. First we will see what are the advantages of the PLC. We are having so many advantages of PLC rather than the disadvantages. Okay. First we will see the advantages one by one. First one is the flexibility. What is flexibility? Flexibility means in the past, each different electronically controlled production machine required its own controller. 15 machine might require 15 different controllers. That means in the relay, while doing in the relay logic control, if you are using the product 15 machines, that means to control that we need 15 machines. 15 different controllers are needed to control those 15 machines. But if you take the PLC to run all those 15 machines, only one PLC or less than one PLC can be used to run the 15 machines. Less than one PLC means a PLC it can run more than, it can control more than 15 machines. Okay. And next second one is the implementation changes and correcting errors. So implementation changes. See, in case of relay logic control, if your program needs any alteration, if you want to change any program alteration, you want to do rewiring in the circuit. And then what you have to do is you have to go to the floor and you have to rewire your design. And this is a very time consuming. Okay, but in case of PLC program or sequence design change is made, you can easily change in your system using the keyboard within a matter of minutes. Okay, and even to correct the errors, in case of relay, what you have to do? You have to go to your factory floor and there you have to change the wiring. You have to check it and you have to rewire it. But in case of PLC, you can do by using your system itself. It will take only matter of minutes. Third one is large quantities of contacts. See, for example, if in any design, if you want to add contacts, if you consider your relay logic control, already if you want to add some more contacts to your design, what you have to do is first you have to procure the relays and then you have to go to the factory floor and then you have to install it. This is a lot of time consuming process. In case of PLC, if you want to add a number of contacts in your this design, you can easily add in the programming itself. Fourth one is lower cost. Today, increased technology makes it possible to condense more functions into smaller or less expensive packages. See, lower cost means here in case of relay logic control, if it is for bigger design means again it will take, the cost will increase. But in case of PLC, even for larger system, the cost will be less. Now you can purchase a PLC with numerous relays, timers, counters and sequencers and other function for a few $100s. Next one is pilot running. What is pilot running? In case of PLC, you can check after doing your program, you can check the output in the system itself. Okay, the program can be typed in, tested, observed and modified if needed, saving valuable factory time. So in the system itself, you can design it, you can test, you can do everything in the system itself. So here, like in case of relay logic means you need to go to the factory floor and there you have to check everything. Okay, so here it is you can save the factory time in case of PLC. Visual observation. A PLC circuit's operation can be seen during operation directly on a CRT screen. In case of PLC, after designing your program, you can, by giving inputs, you can check the outputs there only. If any errors are there only you can correct. Okay, the operation or misoperation of a circuit can be observed as it happens. Logic paths light up on the screen as they are energized. Here in the ladder diagram, if you click on the input, okay, if it is energized, it will show the light. If it is not energized, it will not show the light. There only we can analyze. troubleshooting can be done more quickly during visual observation. So in this PLC, if any error occurs, for example, for the AND gate, if two inputs are 1, the output should be 1. If we are not getting the output 1, then we can easily trace out the error and we can easily correct it in case of PLCs. But that is not possible in case of relay. It is a very time consuming process. Since relay, it will be having the elaborate wiring system. It is a network of wiring of the components. Next one is the speed of operation. Relays can take an unacceptable amount of time to actuate. Operational speed for the PLC program is very fast. See, in the relays, what happens? It will to actuate that it will take more time. Okay, the response time is very more in case of relays. But in case of PLCs, the response time it is very less. Okay, so here how we are measuring the speed of operation in case of PLC is by scan time. It is in terms of milliseconds. Okay. Next, if the shorter the scan time shorter is there, then the cost will increase. Then next, eighth one is ladder or Boolean programming method. The PLC programming can be accomplished in a ladder mode by an engineer, electrician or possibly a technician. Alternatively, PLC programmer who works in digital or Boolean control systems can also easily perform PLC programming. In a PLC programming, we are having different programming languages like your ladder programming, and you are having the instruction list, and then you are having the functional block diagram, etc. The commonly used programming languages are functional block diagram and the ladder programming. Okay. The next advantage of PLC is reliability and maintainability. Solid state devices are more reliable in general than mechanical systems or relays and timers. Consequently, the control system maintenance costs are low and downtime is very minimal. See, in the mechanical system, that is in the relay logics, the wear and tear of the components is more compared to your PLCs. The solid state components are more reliable than your mechanical system components. Okay. Next one is documentation. Documentation means in case of PLCs, when you do a design, okay, what you can do is you can easily take the printout of that there itself, printout of the design, and you can save it for the future use. There is no need to look for the blueprint of the circuit in remote files. But in case of relay logic, it is not possible. For those things, you should have a blueprint in the relay logic control. So, documentation is very difficult in case of relay logic control. And some other advantage of PLC is one more is security. The security of the PLCs is good. You cannot alter any design until unless it is unlocked. So the security is more in case of PLCs. But in case of relay logic, anybody can go to the factory floor and can easily change the design. Okay. And the one more advantage is ease of changes by reprogramming. See, in case of PLC, if you want to change your design, you can easily change it in your system within a matter of minutes. But in case of relay logic, you need to go to the factory floor and there you need to do the changes. Again, it's a very time consuming process. These are some of the advantages of the PLC. Okay, and now let us see what are the disadvantages of the PLC. Till now we have seen so many advantages, right? For everything there will be advantages as well as disadvantages. Now we will see disadvantages of PLCs. The first one is fixed program applications. Some applications are single functional applications like your drum controller or sequencer. It will be having only one function. So it does not pay to use a PLC that includes multiple programming capabilities if they are needed. Their operational sequence is seldom or never changed. So the reprogramming available with PLC would be necessary. So for the fixed applications, only for the single function applications, it is paying so much is not worth. Okay, that is what it is. Fixed program applications. Newer technology. Always when you come for the new things, changing from older one to newer things, it's very difficult. Same thing even in case of this PLC also, all were comfortable with the relay logic control. Then again changing from relay logic to PLC computer concept, it was bit difficult for everyone. Okay. And it is difficult to change the thinking of some personnel from ladders and relays to PLC computer concept, and also it increased the cost in the industries also to changing for the newer technology. Initially it was cost was more, but compared to relay logic, this PLC has more advantages. And the third disadvantage is environmental consideration. Certain process environments such as high heat and vibration interfere with the electronic devices in PLCs, which limit their use. These are all sensitive to your temperature. So it needs some AC facilities and all needed. So a little bit maintenance will be high. Next disadvantage is fixed circuit operation. If a circuit is in operation is never altered, a fixed control system might be less costly than a PLC. For example, if you are using a PLC for only one single function, that is only for single circuit operation, then going for PLC is not worth. You can use for only single function applications, you can go for relay logic control. That will be less costly than your PLC. The PLC is most effective when periodic changes in operations are made. If you are reprogramming your design, then the using PLCs will be the most effective. The fifth disadvantage is fail-safe operation. What is fail-safe operation means? If any problem, for example, let us consider your lift. Okay, if you'll be in the fourth floor, then suddenly if power goes up, what happens? It will come to the ground floor and then the door will get open. That is called as fail-safe operation. Even if the power goes off, no need to worry. Okay. But in case of relay systems, what happens? The stop button electrically it will disconnect the circuit. If the power fails the system, it will stop. But in case of programmed PLC, what happens? You need to apply some input voltage to stop your device. These systems, these are not fail safe. These are some of the disadvantages of your PLC. Compare your advantages and disadvantages. The advantages are more in the PLC. That is why today all industries are shifting towards the PLC. Okay. Now can we quickly list the advantages and disadvantages of PLC? First we'll list the advantages of PLC. First one is flexibility. Second one is implementing changes and correcting errors. Third one is large quantities of contacts. Then fourth one is it is lower cost. Fifth one is pilot running. Next is visual observation. Next is speed of operation. And then ladder or Boolean programming method. Reliability and maintainability. Documentation. Security. Ease of changes by reprogramming. These are some of the advantages of PLCs. And what are the disadvantages of PLC? First one is newer technology, then fixed program applications, Then next one is fail-safe operations, and next one is environmental considerations, then fixed circuit operations. These are some of the disadvantages of PLCs. Now we will solve some multiple choice questions based on this topic. The first one, how is the noise immunity of PLCs to electrical noises as compared to that of conventional relay controllers? So noise immunity of PLCs. Option A, poor. Option B, excellent. Option C, as good as noise immunity of conventional relay controllers. D, it is unpredictable. Noise immunity of PLCs to electrical noises. It is excellent in case of PLCs. And second one, dash of PLCs can be done in very little time. Programming, next B is installation, C is commissioning, and the D is all of the above. What is the answer? Dash of PLCs can be done in very little time. Programming of PLCs can be done in very little time. When installation also we can do, then commissioning. So the answer is all the three. Programming, installation and commissioning of PLCs can be done in a very less time. And next, fill in the blanks. Modifying the design is easy in dash. Modifying the design is easy in dash means, is it in relay logic control or PLC logic control? Modifying a design is easy in case of PLCs. Next, fourth one. The speed for PLC logic operation is determined by dash. In the advantages, we have discussed the speed of operation. How we are going to measure the speed of operation in case of PLCs? By scan time. That is in terms of milliseconds. Okay, understood? So, this is about the advantages and disadvantages of PLCs. Though some disadvantages are there for the PLC, but compared to disadvantages, advantages are more for the PLC. So that is why today everyone in all the industries, they are using the PLCs. I hope you understood this topic, and thank you for listening.